When Operation Epic Fury was launched, it was widely understood that Iran could not match the United States and Israel in terms of conventional military power. Since the campaign began, Iran has suffered significant setbacks, particularly within its naval and air forces. However, another factor had been evident from the outset. Iran possesses a range of asymmetric capabilities that allow it to offset conventional disadvantages to an extent. One of the most prominent among these is the use of large-scale drone attacks. Iran has employed this tactic to target not only U.S. military installations in the region, but also critical civilian infrastructure, including oil facilities and desalination plants in Gulf states, as well as oil tankers transiting the Strait of Hormuz. The sustained drone attacks, combined with the deployment of ballistic missiles, have reportedly compelled the United States to redeploy certain air defense assets from other theaters, including South Korea, to the Middle East. At the same time, unverified reports suggest that stocks of certain missile interceptors may be running low. Another challenge is economic. Countering relatively inexpensive drones with advanced interceptor missiles has proven to be extremely costly. This evolving operational environment provides the context and foundation for this presentation. In this video, Defense Updates analyzes why U.S. military needs HELIOS laser in every warship. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Named after the Greek sun god, HELIOS is a multi-mission directed energy system that integrates high-energy laser capability with optical dazzling and advanced surveillance functions. Lasers are highly concentrated beams of light that deliver significant amounts of electromagnetic energy to a target. The output of a laser weapon is typically measured in kilowatts, which indicates the rate at which energy is delivered. In a directed energy weapon, the laser beam focuses energy onto a small area of the target's surface. This intense energy causes rapid heating, leading to localized melting, burning, or structural failure. In some designs, the energy is delivered in rapid pulses, producing sudden surface heating and expansion that generate shock waves capable of damaging the target. When a laser strikes an object such as a drone, rocket, or artillery shell, the resulting thermal stress can weaken structural components or ignite internal materials, potentially causing the object to fail or break apart in flight. Beyond its destructive capability, HELIOS can also function as a dazzler, temporarily blinding or disrupting the optical sensors and seekers used by incoming missiles and drones. The system is further equipped with its own optical sensors, enabling it to perform intelligence, surveillance, and reconnaissance (ISR) tasks. The HELIOS system currently operates at a base power level of approximately 60 kilowatts, with a modular architecture designed to scale up to 120 kilowatts, allowing the system to be adapted for a range of operational requirements. USS PREBLE is the first warship equipped with the HELIOS. On board the vessel, HELIOS is installed on the ship's forward weapons pedestal, a location previously occupied by the Phalanx CIWS. Development of the system began in 2018 when Lockheed Martin was awarded a contract valued at approximately $150 million, with provisions for potential expansion. The contract covered the development of HELIOS as well as the production and delivery of 2 units, one designated for land-based testing and another for operational deployment at sea. The weapon has reportedly been integrated with the Aegis combat system. Viewers may note the Aegis system was designed as a fully integrated combat suite in which the radar, missile launch systems, command and control software, and operator displays function as a unified network to detect, track, and engage threats. The U.S. Navy has recently acknowledged that one of its operational destroyers demonstrated the combat application of a shipboard laser weapon system successfully engaging multiple unmanned aerial targets during a series of at-sea trials. According to Lockheed Martin, PREBLE employed HELIOS system to detect, track, and defeat 4 drones during a Navy-led counter-UAS exercise. Although the event took place last year, it became publicly known only after being referenced in the company's most recent financial briefing. The disclosure represents one of the clearest confirmations to date that Helios has been used to engage aerial threats in an operational maritime environment. Commenting on the demonstration, Jim Teichlet, Chief Executive Officer of Lockheed Martin, stated, "Speaking of amazing technology, we successfully used the shipboard laser system, Lockheed Martin's Helios, to knock an incoming UAV right out of the sky. The Helios weapon system successfully neutralized 4 drone threats in a U.S. Navy-operated counter-UAS drone demonstration at sea, showcasing an opportunity to eliminate drone attacks using lasers and saving U.S. and allied air defense missiles for more advanced threats." Laser weapons derive their effectiveness from their exceptional precision and near-instantaneous engagement speed. Unlike conventional ammunition-based systems, they effectively offer a virtually unlimited magazine, provided sufficient electrical power is available, an advantage that significantly differentiates them from traditional kinetic weapon systems. They also offer substantial cost efficiencies. The cost of firing a laser is largely limited to the energy required to generate the beam, meaning that the cost per engagement can be extremely low, potentially as little as around $1 per shot. President Trump told reporters recently that lasers would soon be able to do the work of Patriot missile interceptors at a lot less cost. "The laser technology that we have now is incredible," he said. "It's coming out pretty soon." High-energy laser systems can be highly effective under favorable conditions, but they are not a universal solution to modern battlefield threats. Environmental factors can significantly affect their performance. Atmospheric humidity can refract laser beams in unpredictable ways, while fog and heavy particulates may absorb or scatter the energy before it reaches the target. In maritime and desert environments, sea spray and sand can degrade sensitive optical components, complicating both operation and maintenance in field conditions. Operational experience has also highlighted practical limitations. For example, 4 50-kilowatt laser systems were deployed to help defend U.S. bases in Iraq against drone attacks in 2024. However, according to a report by the Center for a New American Security, personnel in the field found the systems cumbersome and ineffective during certain operational scenarios. Another inherent limitation is that laser weapons are largely restricted to line-of-sight engagements, meaning the target must be directly visible to the system for the beam to remain effective. There are also supply chain considerations associated with advanced laser technology. High-energy laser systems often rely on rare earth elements, such as ytterbium, which is used to dope optical fibers in laser glass. According to a 2024 report by the National Defense Industrial Association, the supply of several such materials is heavily influenced by China. In addition, high-performance laser systems frequently use semiconductor components made with gallium, another critical mineral for which China accounts for a large share of global production. Despite these challenges, directed energy technology remains a major priority for the U.S. defense establishment. Under Secretary of Defense for Research and Engineering, Emil Michael has identified scaled directed energy, including both high-energy lasers and high-power microwave systems, as one of 6 critical technology priorities for the United States Department of Defense. To accelerate innovation and reduce costs, he has also encouraged greater participation from smaller technology firms in competing for laser weapon development contracts, with the aim of expanding the industrial base and driving technological progress. Iran appears to be attempting to shift the nature of the confrontation from a primarily military contest to one that also exerts significant economic pressure, using its large arsenal of unmanned aerial systems as a strategic lever. The United States Navy has been highly effective in limiting Iranian operational options. For instance, U.S. naval forces have reportedly destroyed several vessels involved in mine-laying operations. Nevertheless, certain operational scenarios remain challenging, where the Navy may find it difficult to assert control to the extent it would prefer. One such example is the protection of commercial shipping. Escorting oil tankers through the Strait of Hormuz could become increasingly complex if confronted with sustained drone threats. Large-scale drone attacks pose a particularly difficult defensive problem. When numerous unmanned systems approach simultaneously, air defense networks can struggle to effectively track and prioritize individual targets. Traditional missile-based systems may quickly exhaust their available interceptors, and in some cases may not be optimized to engage large numbers of small, low-cost drones. In this context, laser weapons appear to offer a particularly promising solution. It is increasingly evident that future U.S. Navy warships will likely require laser systems to complement conventional hard-kill defenses. The U.S. military's exploration of laser weapons dates back several decades. In 2010, the United States Air Force successfully mounted and fired a megawatt-class chemical laser from a modified Boeing 747 as a part of an experimental missile defense effort. Since then, the technology has advanced considerably. Modern systems increasingly rely on solid-state lasers, which are significantly more stable, compact, and practical for operational deployment than earlier chemical laser designs. Systems such as HELIOS represent the culmination of these advances, and it is a significant milestone that the weapon is now undergoing operational testing aboard active warships. It is now important to quickly address remaining technical issues, transition the system into serial production, and progressively deploy it across a larger portion of the fleet.